Have you ever thought about a speed limit for the entire universe? I mean, a rule that nothing, and I mean nothing, can ever break. Well, there is one. And once you get it, it completely changes how you see, well, everything.
Okay, so listen to this. It's from the Apollo missions. You'll notice there's this kind of weird, awkward pause in every single conversation with the astronauts on the moon. That little delay, it's not just some technical glitch. Nope. It's actually a massive clue about how the universe itself works. And stick with me, because we're going to figure out exactly why it's there. So, the whole secret boils down to one letter, C. That's the symbol for the speed of light. But here's the thing, it's not just about light. It is the ultimate, absolute speed limit for everything in the universe. We're talking information, spaceships, anything you can imagine. It's a cosmic law you just can't break.
All right, so just how fast are we talking here? I mean, it's a number so big, it's kind of hard to wrap your head around. Let's try to put it in perspective. Okay, picture this, a race to the moon. If you were on a commercial jet, well, pack your bags, because it's going to take you weeks. The super powerful Apollo rockets, they got it done in about 3 days. Pretty impressive, right? But light makes that same trip in just 1.3 seconds. I mean, come on, it's not even a competition. So there's the number right there. That's the universal speed limit. But what does that even mean? Well, think of it this way. In the time it takes you to blink your eyes, a beam of light could have zipped around the entire Earth 7.5 times. Yeah, it's ridiculously fast. And that incredible speed, that's the exact reason for that weird delay we heard with the Apollo astronauts. Because even moving at the fastest possible speed, the distances out in space are just so huge that nothing is instantaneous. You see, a radio signal, just like light, travels at sea. So to get a signal from Earth to the moon and then get a reply back, that round trip takes 2.6 seconds. And boom, there's your Apollo delay. Now think about Mars. You want to have real-time chat with a rover on Mars? Forget about it. Depending on where Earth and Mars are, a single round-trip message can take anywhere from 6 minutes all the way up to 44 minutes. Okay, this is where things get really, really wild. Because light takes time to get to us, whenever you look up at the stars, you're not seeing them as they are right now. You are literally looking into the past. It means the night sky is our very own time machine. So, you want to take a little trip? All right, first stop on our tour, Sirius. It's the brightest star in our night sky. When you find that super bright spark up there, just remember, what you're seeing isn't happening in the present. Nope. You're actually seeing it as it was 8.6 years ago. That's how long it took for its light to travel all that way through space just to hit your eyeball. I mean, the light you're seeing from Sirius tonight is older than your average second grader. Think about what was going on 8.6 years ago. When that light first started its journey, the iPhone X had just come out, and you couldn't escape songs like Despacito or Shape of You. It's wild to think that if someone on a planet around Sirius had a super telescope, they'd be watching those things happen on Earth right now. Okay, let's jump even further back in time. Our next destination is Vega. It's another really bright star, and it's a super important one that astronomers use as a kind of celestial measuring stick. The light we see from Vega tonight, it started heading our way 25 years ago. We're not talking about a few years ago anymore. We're now looking back a whole generation. So what was happening on Earth when this light left Vega? Well, people were lining up for the very first Harry Potter movie. A new website called Wikipedia had just popped up, and Apple, they'd just unveiled this weird little white box called an iPod. Wild, right? Okay, so up to this point, we've been looking back at stuff most of us can remember. But now, we're about to take a leap. We're going from personal history straight into deep world history. And to do that, we're going to look for probably one of the most famous stars out there, Polaris, the good old North Star. So when we look at Polaris, we're not seeing light from 25 years ago. No. We are seeing it as it was around 400 years ago. This is a huge, huge jump back. So what was Earth like 400 years ago? Well, a guy named Galileo was pointing his brand new invention, the telescope, up at the sky for the very first time, changing science forever. And halfway across the world in India, construction was just getting started on the incredible Taj Mahal. The light you see from the North Star tonight is literally a relic from that time. Okay, get ready for our last jump. And this one is the big one. We're about to travel so far back that we leave all of recorded history
All of human history, really, in the dust.
Our final destination is the Andromeda Galaxy. Now, if you're in a really dark spot, you might see it. It just looks like a tiny, faint, fuzzy cloud. But that little smudge? That's an entire other galaxy, filled with 1 trillion stars. And it's the farthest thing you can ever hope to see with just your own eyes. So how old is the light from that fuzzy little patch? It started its journey to us 2.5 million years ago. Just let that sink in. When the light you see tonight first left the Andromeda Galaxy, modern humans didn't exist. Our species, Homo sapiens, wasn't even around yet. Our ancient ancestors, creatures like Australopithecus, were still wandering the plains of Africa, just starting to figure out this whole using stone tools thing. So you see the pattern here, right? From the 1.3-second hop to the moon to the incredible 2.5 million year journey from Andromeda. The speed of light doesn't show us a universe that is, it shows us a universe that was, layered in all these different moments in time.
Okay, so looking up is looking back. Got it. That's all because of how long it takes light to travel. But what about the speed limit itself? Why does this one number, c, matter so much? Why is it so crucial to how the universe is built? Well, it turns out it's the magical ingredient in the most famous equation in all of science, E equals mc squared. That c in the equation is the speed of light. And because that number is so gigantic, what Einstein's equation tells us is that you can take a tiny, tiny bit of matter and convert it into a truly mind-blowing amount of energy. So the next time you're outside on a clear night, just remember what you're really seeing. It's not a single moment in time. It's like a cosmic photo album, with pictures from millions of different years all arriving at once. Every single star is a messenger from the past, traveling at the only speed allowed. It really makes you think, doesn't it? When you look up at the stars, are you seeing the present, or are you just looking at the beautiful ghosts of the past?